Hello everyone, welcome back to my channel. This is your host Mohan and you are watching MSSQL DBA Series. This is our fifth video in series, and before that we have uploaded four videos. On that we have discussed about the fundamentals and DBA roles, installation and configuration of SQL Server. Then we have discussed about database and database files and few database settings. So before moving ahead with the topics for today's video, I wanted to tell you that creating videos like this requires significant effort to ensure accuracy in every query and configuration. If you really value this kind of DBA focused content, please like, share, and subscribe to this channel so I can keep creating such content for you. By the way, I'm curious to know about our community's background. So just let me know in comment about your years of experience in working with the database or with the IT industry. With this, let's start with the topics. So in today's video, we are going to see about the CRUD operation. So CRUD means create, or we can say insert as well, read, update, and delete. So those are called the CRUD operations. Then we have the SQL clauses where group by, having, and order by. Then we look into the count, sum, average, min, max, all those aggregations. Then join in subqueries, and we will look into the transaction basics like begin, commit, and rollback. Then we see about the asset properties, atomicity, consistency, isolation, and durability. And in the last, we will look into the index basics. We will cover the clustered index and non-clustered indexes. We always do. We will cover some interview questions around the topic. So without any further delay, let's move to the SQL Server Management Studio. So here is my SSMS and this is my database test. Those are the table which I have created earlier. So now let's start with creating a table. To create a table, we need to write create table statement. So it is starting with create table, and then we need to give the name of the table. Let's give it a name as sales. Then we'll open the parenthesis. We will give the first column name, and this will be our primary key. Column name is sales ID, and int will be the data type. And here I will say this will be our primary key, and I will give it as identity. It means it will start from 1 and increment by 1. So every time when you insert any record in sales table, you need not to insert this sales ID again and again. You can also keep it as 100 or 1000, whatever your requirement is. You can start your sales ID with that. Then we will write the name of another column, that is product name, and I will give it as varchar. So I will give varchar 100 because name can be number. Then category, and category I will again give varchar and I will give it as 50. Then amount, so this will be in decimal because we will write as 100 rupees 50 paise or something. So it will be total 10 digit and 2 digit after decimal. After that, I will give a column name as sale date, and this will be a date type column. Yeah, so this is how we write the syntax for create table. At present, if I will try to run the statement, right, select star from sales, it will not give any data because the sales table is not present. That is why it is saying invalid object name. When I run this statement, it will create a table, and now I can see that table is there, but there is no data because we haven't inserted any data in the table. And we can also go here and click on refresh. Then we will see the sales table here. So this is how we create a sales or create a table, and this is how you select from the table. Now let me show you multiple methods of inserting the data into the table. So first method is very common, that is we write insert into, then we write the column name. So let me write the column name. So first column name is sales ID, but we will not mention that because it will automatically inserted and started with 1 and it will increment by 1 as per the configuration of the column. So I will write product name, okay, comma, category, then amount, then sale date. So after this, I will write values. This is a keyword. Then I can put the values. So for example, our name of the first product is laptop, and it belongs to electronics category, and the amount is, for example, 75,000 per character string where if we are giving, we need to give inside this single quotes, and the number it can be without, it will be without single quotes. Then we have the start date. So date also we will keep inside the single bracket, single quote. So it will be 1st February 2026, and I will close this parenthesis. And when I run this statement, okay, there is some issue here. Sorry, I haven't given the name of the table. So insert into sales, then all the column names, and then value of those columns. My bad. Now it says one row inserted, and if I will run select star from sales, I can see the data is already there. This is one way of inserting the data. Other way is like we can say insert into sales, and we can give the name of the columns, and we can give multiple category here. For example, instead of a laptop, I will say a smartphone. This will again be inside the electronic category, and I will say it is costing 25,000 and sales date is 2nd February. I can again go here, copy paste this one, and I can give comma, and I will again update the values. This is desk chair. We can say it is furniture, and costing is 15,000 and the date is 3rd of February. Again, comma, and I will give another row, and here I will say monitor. This will be electronics only, and I will give it as 10,000, and this is 4th one. Okay, so this is another way of inserting data into the table. So 3 rows are inserted, and I can again run the query select star from sales. We can see that 4 rows are there. Please make note that we haven't given any name of this sales ID, or we haven't given any record, or we have not inserted any record with this column in this column, but here we can see it is incrementing by 1 by default. That is the importance of the identity column. After that, I will show you one another way of modifying this, or maybe inserting a row into a table. So here you can see the table. You can right click and give like click on edit top 200 rows. Here you can write for example table, and it will be inside furniture category, and amount is for example 8,000 rupees, and the date is 2026 02/05. And you don't need to do anything, just close this and it will be automatically saved. And here when you run select star from sales, I can see that table is added into the furniture category. Whatever details we have entered, it is showing here. So this is another way of entering or inserting the data into the table. So I have shown you 3 methods of inserting the data into the table, and we have also seen how you can select data from the table. Now for example, if I want to rename the column names, so if I want to update the name of the column category to something else, so I can, there are 2 ways of doing that. So one is we can say exec sp underscore rename. So this is a system stored procedure for renaming anything. So I will say exec sp underscore rename, and I will say this is a sales table, and inside that we have a category column. Okay, and in that column, I want to update this column as, for example, if I have misspelled it and I want to correct it, I can write CAT, only CAT. If I want to write, I will again give it inside the single quotes, and then I will give what is this value. So this is column. Okay, so here it is exec sp underscore name, sales is the table name, category is the existing column name, and this will be the new column. And as this is the column, we will write as column. So if I will execute this stored procedure, it will change the column name, and now I can see the column name as cat. And there is another way of changing the column. I will just refresh this, and I can go to the table, go to the column, And now I can give the name as a category. I can simply right click on the column name and rename and just enter. So now you can see the name of the column is again changed from cats to category. Yeah, so these are the ways we can change the name of the column if you want. Other thing is if you want to fetch the records, for example, if I want to fetch only electronics that cost more than 20,000, so in that case, we will use the clause. So let's see how we can use the where clause. What we want to select, we want to select the product. We want to select the product name and amount, and the table name will be sales. And what will the condition where amount is greater than, for example, 20,000. So as per this query, it should return laptop and smartphone because they are costing more than 20,000. So let me run this query. Yes, so we can see there are two records. Now, if I want to give a discount on some of the uh, electronic items, then we can update the price here. So I will run the update statement. So I will say update and the table name. I will set amount equals to, for example, if I want to update this smartphone, I want to give the discount of 5,000 rupees. So the new value or new price of this smartphone will be 20,000. So I will say set amount, whatever amount I want to set, I want to set at 20,000. And I can say where, you can say product name equals smartphone. This we can write, as well as we can also write where sales ID. Yeah, we can write where sales ID equals to 2. So whatever you want to write, you can write. And if I will run this statement, the product price is updated. So phone price will be now showing as 20,000 instead of 25,000. 25,000. So this is how we run the update statement. So now if I want to update the category, for example, this is the current category furniture, and if I want to rename it to say office gears, how we can do that? We can update the table. So we can say update sales, and after that I will say set, and I want to update the category. So I'll say set category equals to what will be our new category name. It will be office gears, and I will give the where condition where category equals current category name, that is furniture. Okay, now if I will run this statement, it says like 2 rows affected because we have two furniture in the category earlier. And now if I will run the statement, select a star from sales, then we will see that it is updated to office gear. So this is how we update the category or anything. If you want to update, for example, if there are similar product name and if you want to update the name, so you can update by using the update statements. So now what we have seen how we can create a table, how we can insert the data, how to select the data, and how to update the data. So after that, we will see how we can delete the data. For example, if I want to delete smartphones from here, so I will say delete from sales where sales ID equal to 3, or we can also say where product name is equal to smartphone. So if you will say product name equal to smartphone, so all the product name which has the smartphone as name, those will be deleted. But if we delete from ID, only that particular specific one will be deleted. So it is 2. So here if I will run this, it will delete the smartphone from the table, right? So we cannot see smartphone now. And if I want to delete all the records from the table, we can simply say delete from the sales. I will show it at the last. So as of now, for example, if I want to delete all the orders which has been placed after the 3rd of February, so we can write delete from sales where sales date is greater than this value. Okay. So once I will write it or I will execute it, it will only have the rows that is first and third, like the laptop and desk chair, because those order were placed before the 3rd of February. Let me quickly insert the data again, maybe. Okay. So now we have 1, 2, 3, 4, 5, 6. We can see the sales IDs are missing because it is incremental in nature. So that's why you can see 6, 7, and 8 as sales ID for the new insertion which I have done. Okay, so now we will look into the group by, how we can use the group by. So in SQL, group by clause is used to arrange the identical data or similar type of data into the groups, and it is almost always used in the conjunction with the aggregate functions like count, sum, average, min, or max to perform the calculations on each group rather than the entire table. And you can think of it as the summarize by command. If you have the list of for 50 sales or 100 sales, group by allows you to see the total sales per city or per the number of items sold per category. So let me show you how we can use the sales. So here, for example, if I want to calculate the total revenue for each category, so in that case, I will write select category, then I will say sum of amount. So it will show the amount, like it will sum all the, so it will sum all the amount for that particular category, and I will give the alias as total revenue from table name sales. Now I can say group by column name category. So what this command will do, it will show the category and it will also show the total amount for that particular category. So here we can see we have electronics, office gears, and furniture. 3 categories we can see. So in the output, we will see 3 categories and total amount. So here we can see electronics, total revenue is 1,10,000, then furniture, then office gears, and total revenue we can see here, right? So this is one way of using the group by. Second way of, so other example will be if I want to count how many items were sold on each day. So I will say select sale date, then I will say count of sales ID as item sold. So every record will have one sales ID. That is why we are giving this count sales ID. We'll count the sales ID as and we'll give the alias name as item sold, and we'll say from sales. And now I can say group by sales date. Right? So what it will do, it will count each and every sales ID. It will count for that and it will group by as per sales date. So we can see in the output, we will see all those dates 1, 2, 3, 4, and we'll see how many items were sold on that particular date. Here we have 4 dates and we can see the items sold here. So this is how we can use the group by commands. And now we will look into the order by. So in SQL, the order by clause is used to sort the result set of a query in either ascending or the descending order. By default, SQL Server does not guarantee the order of the results. It retrieves them in whatever way it is the like a fastest of for the engine. If you want your data to appear in the specific sequence, like dates from the newest to oldest, or names you want to show as alphabetical order, you must use the order by. So if I want to see the most recent sales first, I will say select sales ID, product name, and sale date and amount. I will say from sales. And then I will say order by sales date. Okay. So once I will run this query, it will order the table data or the whole data in the sale date format. So here, and I will say descending or DESC. then DESC. So once I will run this statement, it is giving the result in the order as we have described in the statement. So here, sales date, you can see it is descending. So it is showing the latest data first and then all the data in the descending order. If I will write ASC, it will simply give me the data in the ascending order. We can write amount as well if I want to say it like amount wise. So I will say amount ascending. So it will give me the lowest amount first and the highest amount later. So you can do order by in any column and you can fetch the data as you want. Now I will show you how you can use the aggregate functions. For example, if I want to say, if I want to see how many total sales were made in our company, so you can say select count star. So count star means it will count all the rows as total transactions from sales. So what it will do, it will check all the rows and it will count each row. So here, if I will run the statement, we will say that it has total 5 transactions. Or if I want to see the total revenue from my company, I will say select sum of amount, and here I will give as total revenue from sales. So it will sum all the amount in all the rows and it will give me as total revenue. So we have made sales of 1,40,000 in total. So this is the use of some aggregate functions. Then we have function. Then we have average. So if I want to say what is the average sale value, I can write select and I will give function name as average and I will write here amount as column name and as I can give as average sales from sales. So here we have 5 rows and we have different amount in each row. And this query when we run, or this function when we run, aggregate function, it will just sum all those amount and it will divide by total number of rows, that is 5. So let's see how much it will give. So it is giving 28,000 as average sales for our company. And then after that, we can go with the min and max. So we can write select minimum amount as smallest value, and we can say max amount as highest value from sales. So it will scan all the records of sales table and it will check what is the minimum amount and what is the maximum amount out of all the rows. So here we can see we have 5 rows and the maximum amount is 75,000 and minimum is 10,000. So it should show that data to us. So it is showing smallest value as this and highest value is this. So this is an example of min and max. Now, if I want to aggregate for just electronics category, how we can do that? Let me run this again. Here is, so our goal is to aggregate just for the electronics category. So I will write select count star as electronics count. And then if I want to sum the whole amount it has generated as electronics revenue from sales. And I will give the where clause where category equals to electronics. So this it will count all the rows where we have the category as electronics and it will sum all the amount for that electronics category. So here we can see we have 1, 2, 3 total category and the amount if we see it is 15, 75, 1,10,000. It should show us. So let's see. So yeah, this is total count is 3 and electronic revenue is 11 or 1,10,000. So this is how we use different functions, count, sum, average, min, and max. So this is just an overview of those functions and how we can insert or update data. I have created a whole development series for SQL. If you want to learn the development or SQL development from scratch, if you want to become a pro, you can follow those videos. And in those videos, I have mentioned everything in detail. So what is a join? As its name suggests, join means combining two things. So here in case of SQL Server, we are combining two or more tables together using the join. But we have to keep in mind that the two tables which we are joining, in those two tables, there should be a same column name. Here, what I meant by same is they should have the same data type. The name of the columns may be different, but the data type or the values which we are storing in those columns must be the same. So that is called the join. So let's understand about the first join, that is called the inner join. So inner join, what it does, it basically combines two tables and it will display the records which are common on two tables. So for that, we need two tables. Here I have already created two tables. Let me show you. So I have one table called alpha and I have another table called beta. So this is just for explanation. Those are very simple table with only one column and the data type of both the table or the single column is same. So here, if I want to retrieve the record which are common in both of the tables, I can use the inner join. So what is the syntax of join or inner join? I will write select star from first table. So first table is alpha, and then I will write inner join. This is a keyword inner join. And now I will write the next table or the second table which I want to join with alpha. So here it is beta. And I want to write on which column I want to compare. So here in both the tables, this is a very simple, these are very simple tables, and here only one column is there. So we are going to compare that column only. So here in the on, we can give the condition. Here I will write the name of the table alpha dot name of the column alpha dot alphabet equals to beta dot alphabet, right? So this is a very simple example of inner join. Let's see what it does. I am just taking the screenshot of this to show you what actually it does. So here you can see we have four records that is matching, or those are the common records in both the table. So here you see the first table is alpha, and here this is A, and you can see A here as well. So this A is matching with this A, then this C is matching with this C, then we have D also, and then we have next A also. So what it does, it basically checks for all the rows. So here, if you see this A is going to check all the values in next table or the second table, that is beta table. So here you can see nothing is found, only one time A is found here. So it had displayed this A. Now it went to B, it does not find any B in the next table. Then it went to C, here it found the C here in the next like eighth row. Then it went to next and null is found. So null will not be calculated because null means like undefined value. So we cannot compare this. So here it went to D and it found that D also there. And again, it came to A and it compared this A, the eighth row from first table, and it tried to match and it found again this A. So here it displayed those four records which are matching. So this was very simple example. I will show you the same with another table which I have. Now we will see how we can use this inner join in different tables. So for that, we have a table called students. So I will show you what is the data here. Select a star from students here. And then we have another table called courses. So select a star from courses. Here we can see we have student ID 12345 with the name John, Lisa, Mark, Sophie, and Charlie. And we have course ID was 101, 102, 103, 104. And we have math, science, English, and history as a course name. And here we can see that John, that is having student ID 1, he has enrolled for maths as well as for English. And Lisa has enrolled for science. And Mark with the student ID 3 has enrolled for history. But Sophie and Charlie, they have not enrolled for any of the courses. And here in both the tables, we can see that student ID is a column name, which is having the similar data or similar or same data type here. So what we will do, we will compare both of these tables using the inner join. I will write the select first, and I will write I will write the two tables name here. So students, and then I will write the inner join, and the next table is courses. And I will give the condition on. Here I will write students dot student ID equals to courses dot student ID, because this is the column which is similar or same in both the tables. Now what I want to select, I can write in the select statement. So there are multiple ways to write here. Here we will write the table name first, students dot. We want to write the student ID here, students students dot student ID, and then I want to say courses dot course name, and then I want to have the name of the student as well. So that is in the students table. Sorry, students dot name. Here we are selecting student ID from student table, and we can have a student ID from any table because it has in both the tables, and courses from course name and student from like name from students. So when I write this query, let me take the screenshot of these tables so that I will explain you later how this will work, and I will try to run this statement. And here we can see we have two tables, and it has joined the two tables, and it has displayed the common records from both the tables using the inner join. Here we can see first it tried to check this record John, and it tried to check the student ID 1. It has found the student ID 1 in the next table or the second table, and it has displayed the record as student ID 1, course name is maths, and name is John. Now it went ahead and it tried to compare those this one student ID 1, and it has found student ID 1 here again, and it displayed in the second row. And then similarly, it tried to match the student Lisa here, and it has found the ID2 here, and it displayed the name of this student Lisa with the student ID and the course name. And it has again gone for student ID 3, and it has found the student ID 3 here with the history. So it has displayed all those records. For other records like Sophie and Charlie, as we know that they have not enrolled for any of the courses, that is why it does not appear here. So this is how this inner join works. And one important thing here, that like you must have seen multiple ways to write those aliases, you can say, like a table name here. So important thing to note here, that if any column is present in both the tables, then only you need to write the name of the that particular table and the column name. So here in our example, we can see this course name is present only in courses table. So even if we don't write here courses dot, it will give the name of the courses, and here the student name also that is present in student table only. So we need not to write this as well. It will display the same result, correct? And there is other way we can write it, like student we can give the name as alias as, and here courses as C, and we can use instead of the whole name, I can write as dot student ID. And yeah, here if we want to write, we can also write the name like s dot name here, or if I want to write C dot course name, you can write this way as well. And here also you can use s dot student ID and C dot student ID. So there are multiple ways you can write those statements. Now I will go ahead and explain about the left join. So left join is in SQL returns all the records from the left table and the matching records from the right table. So whatever name we will write before the left join, those will be considered as the left table, and it will display all the records from the left table, and only the matching records from the right table will be displayed in the left join. And we also called it as a left outer join. One more thing I forgot to explain here in our last example, that inner join is the default join. Even if I don't write the inner here, it will give the same result. So this join, if you write only join, it will consider it as an inner join. Okay. Okay. Now let's move with the left join. So this left join is also called left outer join. Again, I will give the example from our two tables. Select a star from alpha, and here select a star from beta. So as I said, it will display the all the records from the left table and display only the matching records from the right table. I will if I want to write the command here, so I will say select a star from alpha, then left join beta. I have written both the table names here on alpha dot alphabet equal beta dot alphabet. So let me first copy this and run this, and here we have two tables. Sorry, 1 minute. Okay. Now let me execute this query. Now let's see how it presented this as an output. As I said that in the left join, it will display all the records from the left, and it will return only the matching records from the right table. So here we can see we have first it is trying to match A with A. It has found A here. Oh, sorry, yeah, here. It has displayed this, and this is the left table, so it will display this record. And here it did not find any matching for the B. So if it does not find any match, it will display the record, but in the second column or second table, it will display as null. Here in the C, it has found this as C. Again, after C, we have null. So null is displayed. Then we have displayed the D. It has matching from record for the D. And again, two nulls are there. And then we have A. And for this A, we have again the matching record in this table. So here we can see that all the records, here we can see we have 1, 2, 3, 4, 8 records in the first table. So all the 8 records are displayed here. But in case of second table, that is we have given as beta, it has only displayed the matching records here. Only A, C, D, and the A again. For this A is displayed, and again for the second time A is there, so it has displayed this A. So only the matching records from the right table is displayed, and all the records from the left table. That is why it is called the left join. We are displaying all the records from the table which is written in the left side or before the left join, and only the matching records from the right table. So now what I will do, I'll go ahead and take the examples of our other tables, students and courses. Okay, so here we know that we have students. We have few students which like those have not taken any courses. Here in the second table, we don't have any courses for Sophia and Charlie, but still we want to display the records. So we want to return all the students and their courses, including those who have not enrolled for any courses. In such case, we can use our left join. I will write select s dot student ID, or maybe write first the table name so that I will get the table columns as well. So the students, I will give this as S, then left join and we will give it as C. On we have common records, we have common column, that is student ID. So S dot student ID equals C dot student ID. Now what I want to display, I want to display all the students. So I'll give the name. Name is in only one table, so I can give name only here. And then I can give s dot student ID. and course name as it is only in the course table. Once I will run this statement, this will give you the result. And here you can see we have all the data or all the rows from table 1. So here we can see student ID 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, all the student IDs are present, and only matching records from the second table. So second table we can see we have matching records for 4. So maths, English, science and history, but we don't have matching records for those two, Sophie and Charlie. That is why we are getting the null only here. So if you don't find any matching record, it will display the value as null. So here, the when we can use the left join, or the use cases of the left join will be where we need to include all the rows from one table, even if the related rows do not exist in the other table, then we can use left join. Or sometimes it is useful in reporting when you want to show all the entries from one side, highlighting the gaps or missing data from the other table. So this is about the left join. Then we have the right join. So right join is in right join in SQL returns all the rows from the table on the right side of the join, along with matching rows from the table on the left side. If there is no match, columns from the left table will be filled with the null values, as we have seen here as well. So it is almost same. The only difference is we need to use right here instead of left, and now it will display all the records from course ID, and it will display only the matching records from student ID. So if I will run this query, it is giving only those 4 records which are in the second table, and it is it is displaying math, science, English and history, and those matching rows which we have find here in the first table, that is student table, first, like student ID 1, 2, 1 and 3. It is not displaying any column which is not matching in the second, here in case of student table. So here it has displayed math, science, English and history, and with the common rows which are in the student table, right? So this is how we use the right join. And after that, we have a full join. So in case of full join, let me write here. In case of full join, it is also called a full outer join. So here SQL returns all the rows when there is a match in either the left table or the right table or the both. And it combines the result of both left join and the right join, including the unmatched rows from both the tables with nulls in place of missing matches. So wherever we have seen, we will find the match, it will display those records. And if it does not find any match on two tables, it will display as null. So first we will understand this from our alpha and beta table. Then I'll go ahead and explain about those student and courses table. Okay, now let me copy. mm, Let me write. So I want select star from alpha. I will write full join beta on alpha alpha dot alphabet equals beta dot alphabet. Here we have seen that it has displayed all the records, whether we have matching records or not. So it will first take this A and it will try to match the A from the next table. Here we have found this A, and next it has checked for B and it has not found any B. So it has presented this as null here in our table. Now again with C, it has found the matching record as C. Then this null value is there. So null is compared with null. Then we have D. This D is compared with D. We already have D here. Then two nulls are there. So we can see those two nulls here. Then this A is matched with A. Right after that, whatever nulls we have like 1, 2, 3, 4, 5. So here we can see those nulls 1, 2, 3, and here we have seen two nulls 4, 5. So those all nulls are displayed here, right? So this is how we can use the full join here, where we will display all the records from both the tables. And even if we don't have the matching records, it will display those columns as well with null. Or if I want to display the same thing with our two tables, that is student and courses, I can write full join. Okay, here we can see the first table, this John is matched with maths, and then John is matched with English, and then Lisa has matched with where is that, science, and this Mark is matched with history, right? Those three column or three rows from here in the first table, it has matched with those four rows, or the four records in the next table. But here for Sophie and Charlie, we don't have any record, so that is why it has been displayed as the course name is null. So here also we can see in the both the tables we have matching records as well as the unmatching records or non-matching records. So this is the use of full join. So when we can use those full join, when you want to when you want a complete set of records from both the tables, or sometimes it is useful in the data comparisons or auditing, or maybe identifying unmatched or missing data across related tables. So this is about the full join. Now, next we have self join. So what is self join? As I have said earlier, that we need at least two table to come to use the join. Here in the self join, we will use the same table twice with different aliases. So in the self join in SQL Server, where a table is joined with itself, so it allows us to compare or relate our rows within the same table by treating the one instance as a left table and another instance as a right table. So self join are mostly useful where we mostly useful for the hierarchical data or finding the relationship with the same data set. So I will show you that with the example. Here we have a table called employee. We have a table employee, and we have employee IDs, name, and the manager ID. So here we can see John Smith is at the top level and he does not have any employee. Other than that, we have all the employees with their manager ID listed here. So here we can see this manager of Lisa Ray is John Smith, and for Sophie Turner, Lisa Ray is the manager. Similarly, we have Emily Davis, where the manager is Mark Johnson. So here what it will do when what I can do, I can take those two table as a different table here, and I can so my main aim here to find the employee and their manager name. So I will write a command select. We'll see first the table from employee. This is only one table. Here I will give alias as E, and then I will write left join here, and I will give the table name again, but this time I will give alias as M. And what I will do, I will say the column name. So here I will have a column E dot manager ID. So from this first table, we will take the manager ID, and from the second table, I will write the employee ID. That is how we will get the manager for the employee. And now I can select here E dot name as employee name, comma, M dot name as manager name. Okay, so let me try to, okay, let me try to take the screenshot of this one here. Now if I will run this query, so here we can see it has taken this employee.e, or employee e means this first table as a primary table or the left table, and it tried to match all the records from the right table that we have given alias as m. So here it is trying to find the trying to check the column. This is first from the first table manager ID column, and from the second table employee ID column. So here it will first display all the records from for left table. So we have all those Lisa, this John, Lisa, Mark, Sophie, everything we have in the output as the first record, as the here in the first column, and then it is trying to match only the common records from the like different as other table. So here we have taken this as a manager table, or m dot, we have given alias as m. So we can see here what it is trying to find. It is trying to find the here it is trying to find the employee name and manager name here. So from here we can see this is so first it has displayed this one, and here it has tried to find this Lisa Ray here. It is displayed, and it is trying to find the name of the manager from this table. So here it has given the manager ID as 1, so it will display this name. Then we have Mark Johnson, again it has displayed this name here. Then Sophie Turner, it has 2. We can see the Sophie Turner 2 is this ID, right? And here next we have David Brown. Here we have seen that it has 2 as a manager, so this 2 will display it, so on. So that is how we can use the left join, or we can say the self join. Self join is a term only. We don't write the word as self. It is only a left join. But in case where we want to display the name of employee and manager, then we use this kind of join. Or we have another table that is called employee 2. Here we can see we have a different name, John, Lisa, everything, and we have the city as well. So they are living in New York, Los Angeles, New York City, and so on. So if I want to display the employee who lives in the same city, we can also use the self join in such case as well. So here I'll take the screenshot of this. Okay. Also let me write the query first here. Employee 2, I will give it as E, and here employee 2, I will give it as C, because we want to write the city. And here I will write E dot city, M dot city. Okay, let me see what I want to display here. Select E dot name, comma C dot name, comma E dot city. So here what we are trying to find is we are trying to find the employee which are from the same city. So here we can see John and Mark, though both are from the same city, and Lisa and David Brown, Sophie Turner and Emily, and from Miami we have only one. And John and David Brown again we have from the Paris. So those are two different employees, and they are from the same city. We want to find the employee name from the same city. So here we are just joining two tables with itself, not M. We try to see here. Let me see what it will give. It will not give the like whole result. Now here we will give the condition. So at present, this is showing uh, uh, all the employees where it is combining both the tables. It is joining both the tables with the same city. So if I run this statement again, you can see that we have all the employees, and only this Miami is the one which is coming at one time. Other cities are coming at twice. So that is why we are having like there we have 9 records here and 9 records. So total we have 18 records, but this record is coming only once because it has does not have the same record like twice. So now what we will write a condition here where, because you can see here that all the names are getting duplicated. For example, this is John Smith and John Smith, again it is coming as twice, and with New York, and we can see again this John Smith coming twice with the Paris. So now what we can write a condition here there, that where E dot name is greater than C dot name, or we can give anything. So what it will do, it will compare both those two tables, right? And if those records, for example here, if we give the condition E dot name is greater than C dot name, so here it will first check the E table or this first table, and it will check for the name. And when the name is not same, then only it will display the record. So by this way, we will not have the duplicate records. So earlier we have seen here, we have multiple duplicate records here. But in case if we give this E dot name is greater than C dot name, I will have only those rows where the names are not same. So these are the employees. You can see these are the name of employees. We have those have the same city. So Mark Johnson and John Smith have New York, Lisa Ray and David Brown from Los Angeles, and Sophie Turner and Emily Davis from Chicago, and John Smith and David Brown from Paris. So this is how we use the self join. So what is subquery? As its name suggests, that subquery is a query inside a query. So we will understand this with more examples here. So we are going to use those two tables. Here we have department table and the EMP table. In the departments table, we have six department with different department ID and department name. And in the employee table, we have total 100 of employee here. And with their names, employee ID, department name, salary, and joining date. So let's move to the example. So we will understand all those examples with some questions or the problem statement. So the first problem statement is find the employees who are earning more than the average salary of all employees. So here first we need to find the average salary of all the employees, and we need to compare this result with the all the employees who and whoever salary wherever salary is more than this average salary, we'll get the employees in the output list. So for that we can say select average salary from EMP, right? Here we will get the average salary. Let me I'll write it here. So we have average salary that is 83,877. We can also give this name or alias average cell. So it will give the column name as average cell. Now I want to find the employees who are earning more than this, right? So there is one way of writing this is select star from EMP where salary is greater than this, right? If we will write this, it will give you output and it will give all the employee name or employee details who are earning more than this average salary. But in real life scenario, this does not work, or we do this is not recommended because we it is not good practice to hard code any value here. This query should be the dynamic one. And here, in case if the salary of employee changes, this will remain invalid. Okay, so for that we will not use that. Instead of this, we will use this query inside our main query. So this is our main query, and here we can give this. So in the inner query, we are getting this result as average salary. In the outer query, we will get the details of all the employees who are earning more than the average salary, right? So this is the perfect example of subquery where we are using a query inside a query. So this is the inner query and this is the outer query. And in the inner query, we are getting only one row and one column. So this is also called a scalar subquery, or we can also call a single row subquery. Okay, so where we are getting only one column and one row in the inner query, then we call it as scalar or single row subquery. There is another way of writing this query as like we have this query where we are getting the average salary. Now consider this whole as a table. So we will consider this as a table, and we can give the alias name of this table as, for example, cell. And now what we will do, we will join this table with another table. What we can write here, select star from EMP, right? And join. I will join this table cell. And if you remember from last videos, when we use join, we need to get the on keyword and need to match the columns. So what are the columns which are common in both the tables? So here in this, we have a salary column or average salary, which we have given the name as average salary. And here that the salary column will be will be having the same data type. So here we can say, we can give this as E alias name. So we'll say E dot what we are taking from here salary, and from other query here salary sal dot average salary. This we are taking, but we need not to use the equal sign because we need to find the employees whose salary is greater than average salary. So I will use this greater sign here, and I will okay. Now I will run this query, and you see we have the similar result. We have the same result as the previous query. The only thing is we are using this subquery in join here, and here in the above example we are using it inside the where clause. So both are correct. There are multiple ways of doing it. You must be wondering why we are getting this average salary column and it is same for all the rows, right? So we can avoid this. Why it is getting? Because we are using the join, and in the join we are using asterisk or star. So it will give the output or rows from both the tables. So from employee table, we have all those columns, and from this SAL table, we are having only this average salary column. If we want to remove this, we can say we don't need column of all the tables from both the tables. We can say e dot asterisk. So now it will give only output of this table. See this, we don't have this column now. So this is a simple example of a single row subquery or scalar row subquery, as it is only returning one row and one column in the subquery, which is this one, right? Uh, but we also have a subquery that returns one row with multiple columns, and it is very less known or very less popular subquery, and that we can say that as a row subquery or a row valued subquery. Let me write row subquery or row valued subquery. Okay, let's see this with an example. So if we want to find the detail of department ID, department name, employee name, and salary of the employees who has the highest salary, right? So we have two tables. We know that we have the two tables, department and EMP. So just notice that in the employee table, we don't have the department ID. We have department name, but we don't have the employee department ID here. But in this department table, we have the department ID and the department name, right? So first, we need to check all the all the employees. We need to check the highest salary of that employee, and how we can get the highest salary of the employee. We can say select star from EMP, right? And we can say order by salary. If I will execute this, we have all the employees and all the details of employees with their salary. Can we write like we need in the descending order, right? We have all the employees in the descending order. Now, what we can do, we don't need all those employees, right? We only need the top one with the highest salary. So can we write like top one asterisk? If I will run this query, then we will have only one row, right? So we have employee ID 79 and name and department name, salary and joining. So here we see we have only one row but multiple column, and this is the one which is called the row subquery or a row valued subquery, right? So here what we can do, we can use this query here as a subquery, right? And let me give the name of this table as cell, and now we can say select star from here. We need to join this with the department table because we don't have department ID, and as per the requirement we need to get the department ID as well. So I will join this table with the department table, right? And I will say let's say give the name as D join, and this table is joined with this, and we'll give the column name here, so d.dept name, because this is the column which is common in both, and we'll say equals to cell dot department name, right? So now if I will run this query, we will get the employee department ID, department name, employee ID, name, department name, salary, and joining date. So this is what we were expecting in the result. But here again, this department name column is duplicated. You know why? Because here also we are getting the department name from this cell table, and from the main department table we have the department name. So for that again, we can say d dot asterisk, and we will get this one. Sorry, we don't need this. So instead of writing this star, we can say we need d dot dpt id, sorry, dpt id comma d dot dpt name, and from salary or cell we can say cell dot name, right? And what we need, cell dot salary, right? This is what we need: department ID, department name, employee name, and salary. Now if I will run this query, it will give me the desired output. So this is an example of row valued subquery or row subquery, which is a very rare one. Now we will look into multiple row subquery. So multiple row subquery or multi-row subquery, we have two types of multi-row subquery. One is the one where we are getting the multiple rows and multiple column in the inner query, and other one is where we are getting the single column but multiple rows in the inner query. So we will understand again this with an example. For that, we have a question or we have the requirement, we need to find the employees who earns the highest salary from each department, right? So in the output, we will be getting one row for each department, right? So again, I need to refer our table. So here we have 6 departments, and in each department we will have one person or who has the maximum salary, and for that employee we need to find the details. So here what we need to do, we need to first find the highest salary from each department. How we can get that value? We can say select star from EMP, not star, but we need to say the maximum salary, right? Maximum salary from EMP, right here. But here, this is getting the maximum salary of all the employees, irrespective of the department. So I will say department name, comma max salary. And as we are using department name, our non-aggregate column, we need to use group by department name here. Okay, so now we have all the, let me give the name as max cell. We can use as also, and we can use without as also. This will treat it as an alias name. Okay, so we have a department name and the max salary from each department, right? So now we can see here, this is giving multiple column and multi rows, right? So this is an example of multi-row subquery. And if you further dig into it, it will be categorized as two different types of multiple row subquery. So we are looking into first one where it is returning the multiple rows and multiple columns. Now we will use it as a subquery. Okay, and again we will give this we will give this a name. So we can say the name of this one is cell. Now we will say select star from EMP. Okay, and we'll join this one. We can say EMPE, join this cell. Okay, and what is our main purpose here? We need to find the employee who earns the highest salary from each department. So we will say on clause here, and in the on we have the same column department name here, and the same column we have the here, like in the cell this table, right? So and we need to give the condition as well. If I will run this query, it is giving me employee ID, name, department, salary, join date, max salary, everything it is giving. It is not comparing anything, but we need to put one column. We need to put one condition where e dot salary, right? We have e dot salary. This should be equal to what? It should be equal to max salary. So we check the column from here. Cell is the table name. This is the table name, and we are taking the max cell here, right? This is the alias which we have used here, right? So if we will run this query, we will get 6 columns, 6 rows with a 6 department name, different department name, and their highest salary, employee name or employee detail, right? So again, if you see here, department name came twice. You know why? Because now we need to click here and we can say e dot. By this way, we'll get all the details of employees with each from each department. So this is how we use this multiple row and multiple column query, right? Now I will use the example of another subquery, that is single column and multiple rows. Here this one, single column and multiple rows. For that we need a statement of problem statement. So problem statement is find the details of employees in those department where the count of employee is 15. So first we need to find the departments where the count of employee is less than or equal to 15. Once we found the details of departments, for example, we have 2 departments, admin and support, where we have employees more less than or equal to 15. Then we need to find the details of all the employees in those departments, right? This is what our requirement is. So uh, for that first we will find the departments where the employee count is less than or equal to 15. What we can say? We can say select department name, comma count of employee from EMP. Okay, now we can use group by DPT name, right? Group by department name. So here we have all the employees. Let me write it as EMP count. So we have admin, finance, HR, IT, sales, support, and those are the employee count. In our question, we are looking for all the departments where the employee count is less than or equal to 15. So we our query or our need will be only this finance department because it has 13 employees, and one is the sales department because it has 15 employees. Other department has more than 15 employees. So we need only two departments. So can we say having count of asterisk, or sorry, count of employees less than or equal to 15? We can say that, right? So here we have only two employees, sorry, two departments where employees are more than or less than or equal to 15. But as I am saying, I am showing the example of this one where we have single column but multiple rows. But here you see it has multiple columns and multiple rows. So let me remove the department name here because we don't need this here. So if I will run this query, here we are getting the employee count 13 and 15, right? Okay. So now again I will use this query. Instead of count, we can say we need department name. Why we need count? We'll say DEPT name. Okay. Right. We need this two department names here. And now I will use this as a subquery. So let me give the whole one as a name, for example, cell. And here I will say select star from EMP E and join this one cell on what we can do. We have the department name here, so we can say cell dot department name equal to e dot department name. And if I will run this query, we will have all the details of employees who are in the finance and the sales. And how it did it work. First, it is, if you think like this one is as a whole table, like EMP as a one table. So it is saying select star from EMP. So it is taking all the 100 of employees here, but it is joining based on department name and department name here. So first here you see we have this query. It is giving the name of the department only finance and sales. So it is matching those two columns from two different tables. So it is only taking all the employees where this department name from salary column, I mean the finance and sales, will be matching. So that's why we are getting the details of all the employees where the name of the department is finance and sales. So this was an example of multi-row subquery where we have single column but multiple rows. You see this here we have single column and multiple rows, right? Now we have a correlated subquery. So what is correlated subquery? In the correlated subquery, the inner query, for example, here this will be called as inner query. So in case of correlated subquery, inner query is dependent on the outer query for result. So this is called the correlated subquery statement or problem statement. We're going to find the employee who earns maximum in their department. So for that, we will use our EMP table. We'll say select max salary from EMP, right? But we don't need this detail because we don't need the maximum salary of the employee. However, we need this in each department, right? So we can say we can use another query, right? Select a star from EMP. Let me give this as E1 because we already have E2. We can say here. We can say where salary is equal to, and we can keep this as a subquery here, right? But here this will not work properly because we need to give the condition here. What condition we need to give here? That we need a maximum salary for each department here. This is what our need is. So we need to fetch the department from here as well as from here. So there are two tables here. One is the max salary. It is taking the maximum salary, and here it is taking the details of all the employees. So if we will write here where salary equals to, and here if we say we can say like where E1 dot sorry, 1 minute, where E1 dot department name equals E2 dot department name. It is E2 dot department name, right? So if I will try to execute this query, it will give me the expected result. So here we can see we have six names and six departments. So in each department, whoever has the maximum salary, we have displayed here. Now you must be wondering how this result came. So here, just think about the EMP table. Let me run this. So we have this employee table, and here we are saying select star from EMP, where salary. So we are using the salary column here. So consider the first iteration of this one, and here we have salary, and first row we have salary as 45972. Now this salary will be compared with the inner table, and in the inner table we have a max salary from E2, right? So if you remember, and if you have watched my video of query execution, how the query execute, how the order of the query execution work. So if we consider the whole table, this one here, what first will it will check for the employee table, and then it will check for the where condition, and after that it will go with the this max or aggregated column, right? This is the order of execution here. So in the employee, once it will come to this employee table, it will see that this is an E2 employee, and here we are using the where condition. So it will check the department name of this one must be equal to the department name of E1. So here we have already seen that it has fetched this first row. So from this first row, it will take the admin department as per this condition, and then it will check the this E2 table, and it will get the maximum salary of that particular department. So this department name admin is matching here. So we will have after where clause, what will be the output that SQL Server will get as department name is admin only, right? Admin name is a department name which is common in both. So now it will check the maximum salary of this admin department, and then it will give the maximum salary here, and then it will compare, okay, this is the EMP table, and whether this salary of this particular employee is equal to maximum salary. If it is not, it will go to the next row. For example, here it is getting the next row, right? So similarly it will check for all the rows. So if it has 100 rows, so it will check 100 times. That's why correlated subquery is very slow, because it will check for all the rows here, right? So this is how we can get the details of all the employees, where who is earning maximum in the department. Now we have another subquery. Those are called the nested subquery. So in the nested subquery, we use a query inside a query. That is called the nested subquery. So for that, let me give the problem statement here. So we need to find the department where total salary of the department is more than the average salary of the total department. So there are two, three things here you need to find. First, we need to find the total salary of the department. So we need to find each department total salary. We need to find first, and then out of those total, we need to find the average, right? And we need to find the department where the total salary of the department is more than the average salary. So let me see. First, we can get the select a star from, not a star, but we need to find select sum of salary from EMP, but we need it as, if we run this, it will give the sum of salary of all the employees, but we need department wise, right? So we will say department name comma sum of salary from EMP, and we'll say group by department name. Right here we have got the department name and as well as the total salary, right? Yeah, we have found that. Now we have to find the average of this total salary, right? We have to find the average of this total salary. So how we can find the average of this total salary? We can say, we can write here select average of let me give this name, this table name, or alias, we can say, we can give the name as TS. So the whole table, now we will consider this as a table. So here we will give the alias name as a TS. So we will say select average of TS dot, we'll say we have total sale here, right? Here we are getting the total salary of this from this table, right? We can see that we are considering this as a whole table, and now we have given this name as TS, and now we are finding the average of total salary. So let's see what we get here. We are getting this average salary. Let me see AVG cell. Here we are getting average salary of the total of all the departments, right? But now we need to compare this. We need to compare the total salary of the department with the average. Now we have the total as well as we have the average, but we in the average, when we are getting the average salary, we are using the total salary, right? So what we need to do, we need to find it out, and for that, what we can write here, first we consider this as single table and this as another table. So let's see, we have one table as this one, right? So here, from here we are getting the total salary, and from here we are getting the average salary of that total, or we can say here average total salary. So we are getting the average total salary, and this is the average salary. Oh, sorry, this is the total salary of all the departments. Now we want to compare the result of both. So what we need to do, we have to give those as an alias, right? So this, let me give the name of this as TSP. Okay. And again, I need to give this alias as T-cell. Okay. Now we have those two tables. Let me now join those table and compare the result. So here we can say select star from this table, and we can join this table with another one which we have here, right? So we are using two tables. One is T cell and another one is TSP, right? And we need to write the on condition. On, what we need to do, we need to say TSP dot total salary, and we can say total salary is greater than T cell dot average total, right? This is what we need. We need to get the department name where total salary is greater than the total average salary. So here, let me give you one more example here, that we have total, let me write it. What is the total average salary? It is the total average salary. And if I will write the name of, if I will find the sum of total salary, here we have. So in the output, we will get all those whichever the total salary is more than this number, right? So we can see we have this admin department and HR department, and I think there's three departments we'll get in the output. Let's see. Yeah, we have all the departments, three departments where average salary, where the total salary is greater than the average of all those departments. So this is it about subqueries. As we have understood what is a subquery, let's understand the begin, commit, and rollback. So why we use the begin transaction? It will be just in a starting point. By default in SQL Server, it follows the auto commit, means if you are writing any update statement and if you are executing it, this change will be permanent in SQL Server. But if you want to tell SQL Server that I am beginning a transaction that you should not auto commit, then in that case we will use the begin tran. And when we use begin tran, and after we will write some queries, and if we use the rollback, so all the queries which we have written after the begin transaction, it will be rolled back. Or if you are writing the commit after all those statements, then it will be permanently commit. So let me show you with an example here. We have two tables, employees and departments. However, we don't need a department. We only need this employees table. Here we can see we have salary and employee name, department ID, manager ID. And now if I want us to say begin tran, I can write begin tran as well as I can write begin transaction. And here I want to update this table. So for example, I want to update the employees table, and I want to increase the salary of employees by 100%. That is not the real case in real world. It is just in those examples only. So I will say set salary equal to whatever is the current salary, just make it double. Okay, so if I will use this with begin statement, you can see 5 rows affected, and here we will have all the employees, their salary is now double. If I want to make it further, like 4 times, then again this is showing as 4 times of the current salary, right? But now the management decides, oh, we don't want to update the salary. So what should I do now? We cannot go to each table and sorry, each row and just update the statement. Here we are using the begin trend, so we will simply roll back all the transactions which we have written after the begin. I will simply say roll back, and it is rolled back. Now it is the same salary which employees has earlier, right? So this is how we use the begin and the rollback. Again, we will use the begin transaction one more time to show you the commit one. So here, if I will write execute, I will execute this begin tran. And again, I want to update the salary to double. And instead of rollback, I will say commit. So here we can see it is this one. And here commit is done. So salary is increased. We cannot say now rollback because this should be See, the transaction should have the corresponding begin plan because we have started the transaction with begin plan, updated the salary, and we have committed it. Once it is committed, it cannot be rolled back. So this is how we use the begin plan, commit, and rollback. Now, the next thing we will understand the asset properties, that is atomicity, consistency, isolation, and the durability. So in the world of database management system, a transaction is a logical unit of work that contains one or more SQL operations like insert, update, or delete. The primary goal of a transaction is to ensure that even if the system crashes or an error occurs, the data remains accurate and reliable. To guarantee the integrity of data, every transaction must follow the ACID principle. Let's understand what is ACID means. First is atomicity. Atomicity ensures that a transaction is treated as a single and indivisible unit. If any part of the transaction fails, the entire transaction is aborted and rolled back to its previous state. Let's understand this with an example. Imagine that you are booking a flight and you have done a payment using a card, and your payment is deducted and your seat is reserved in your name. So, as per the atomicity rule, if even the step 2, that is reserving a seat, fails, step 1 must be reversed. So you will be getting the refund if your flight is not booked. You cannot have a paid ticket with no seat. So this is how atomicity works. It should be either complete or fail. It should not stuck in between. Then we have the consistency, that is a valid state to valid state. So consistency ensures that a transaction takes the database from one valid state to the another valid state following all the predefined rules. Constraints like primary key, uh, check constraint, and triggers. So consider an example that a bank has said that you should have minimum balance as 500 rupees. Now, if in your account you have 10,200 rupees, and if you try to withdraw 10,000 rupees, the database will check whether after deducting 10,000, whether it will be more than 500 or less than 500. So in that case, it will give you an error that a minimum balance should be 500. So it will not let you uh, withdraw 10,000 rupees. It will give you the error. So that is due to the consistency, because if you will withdraw 10,000 rupees, it will not follow the principle, whatever it is set. So it will give you the error. Next, we have the isolation. Isolation ensures that multiple transactions occurring at the same time do not interfere with each other. So all the transactions should be executed independently, and they should not impact the other transaction. For example, if you have a sale and if you are getting iPhone in e-commerce site, and then this iPhone is the last piece, and if two users are trying to buy this one, the same iPhone, so user one will lock the row for that iPhone, so user 2 must wait until this user 1 buys the phone, or if it removes it from the cart. So the transaction A either should commit or roll back, so the transaction B or the user B will not see a half bought state. So this is how we use the isolation property in our SQL Server environment. We see multiple users are accessing same chunk of data. So we just lock the table for that duration so that other user will not see the stale data or fake data or incorrect data. So this is achieved by the isolation. Then we have a durability. So durability guarantees that once a transaction has been completed, it will remain saved in the system even in case of power failure or crash or system error. So now, for example, if you successfully transfer money to a friend and get a success message, if the bank's server catches fire or loses power 5 seconds or 10 seconds later, your transaction must still be recorded in the permanent logs when the system restarts. It cannot be forgotten. So this is achieved by the durability. So indexes are the SQL Server object which makes our search faster in SQL Server tables. So we basically have two types of indexes. One is the clustered index and another one is the non-clustered index. We also have multiple other types of indexes, but we are not going to talk about them. We will be talking about the clustered and non-clustered indexes only. So with a clustered index, the index is the table. There is no separate place for the data. It means where your table is getting stored at the same place, your indexes will also be there. And the structure, if you talk about the index structure, so it is just a B tree structure where you have the root level, then you have the intermediate level, then you have the leaf level. So in case of clustered indexes, at the leaf level, you will have the actual data pages on that particular table. And about the physical location, as we have already talked that because data is stored physically in the order of the indexes, the data resides directly within the index structure itself. So if you talk about the analogy, so you can think it like a dictionary. So the word, or in our case, it is data, are organized alphabetically. You don't look up a word and then go to another book, right? The word is right there where you looked it up. Or we can say that it is just like a page. So when you open a page, you will have the data inside that page itself. And then we have a non-cluster index. So a non-cluster index is a separate object stored in a separate set of pages. So when you create a non-clustered index on any column, for example, if you have an employee table and you are creating a non-clustered index on a name column, so that particular non-clustered index will be created separately, and it will have a separate page for that particular non-clustered index. And in the leaf level of this non-clustered index, you will not have the data, but you have the pointer of the data. So that pointer or that row locator, either it will be a clustered key if your table is index table, or it will be a row ID if your table is a heap. I will explain it in some time. So as we know that physical location, it is not on the same page as the data. If the table has a clustered index, the pointer is the clustered index key. If the table is a heap, then the pointer is a row ID. Yeah, that's we already have discussed. Then we have a lookup setup. So when you use a non-trusted index, SQL Server finds the key in the index page and then has a jump to a different page to get the rest of the data. The jump is called the key lookup or RID lookup. So let's understand this within diagram. So here you can see this is the clustered index. Here we will have the clustered index key. Then we will have a clustered index key in the intermediate pages. Then we will have data on the leaf pages. So this is how the B tree structure looks like. And here, if you see the picture, we can say that, for example, this 1 to 1000 is a employee ID, and on which we have created a clustered index. Or whenever you have a table and if you create a primary key, so the clustered index is automatically created on that particular column, and you can have only one clustered index per table because there can be only one way to sort the data. So here we can say that this is the index rows. So 1 to 1000 employee IDs are mentioned here. Then in the intermediate node, we have divided, or SQL Server has divided into like four different nodes. So here it has 1 to 250, then 251 to 500, then 501 to 750, and so on. And in the leaf pages, you will have the data row itself. So in the data row, you will have all the information, whatever information is present in the that particular row. Now, if you talk about the non-clustered indexes, so non-clustered indexes will have the key values, then key values in the intermediate nodes as well, and in the leaf node, it will have the row locator. So in this row locator, as I have told you earlier, let me explain it through the example. So here you see this is a heap. So when you create a table without any clustered indexes or without any primary key, so as and when you insert the data into the table, it goes into the random page and the row got stored. So here we can say like here employee ID 1 is here, 4 is here, 6 is here. So it is just a random data. But as soon as you create a clustered index, or as soon as you create a primary key in any column, for example, here we are creating a primary key in employee ID column, so the data will be sorted as per the employee ID column, and this will be called the clustered key, right? So this is how a clustered index looks like, and this is a heap with no clustered index or no primary key. Now, if we talk about the non-clustered indexes, so in case of a clustered table where you already have clustered indexes in employee ID, or if you already have a primary key in employee ID column, then in that case, if you try to create a non-clustered index, for example, in name column, if you want to create a non-clustered index, once you create the non-clustered indexes, then this will be created in separate place or separate page, and in that page you will have the key, the clustered key, which is the name column, as well as this is a clustered index already created, it will have the employee ID value as well, because this employee ID is a clustered key. So this will be the pointer. So as soon as if you are searching with a name, it will simply go and it will check what is the employee ID, means what is the clustered key, and in that clustered key it act just as a row locator, and it will find the value of that particular row. So this is how a non-clustered index work. And if you don't have any clustered index in the table, for example, here the non-clustered index is created in a heap. So In case of a heap, as I said, that we don't have any any sorting method, so this is just a heap. So you can say the data is very random, and every row will have a row ID associated with it. And when you create a non-clustered index on a heap, for example, here again, if we are creating with the name column or non-clustered index on name column, then in that case, this will have the row ID associated with the clustered key. So whenever talking about or we are searching the data where name is Abhi, then it will check the row ID, and this row ID, it will have the information about like where the data is presented. So in that case, you can see that this row ID is pointing to this row ID, right? So here we have a row ID in non-clustered index, as well as we have a row ID in a heap table. So this is how we just this is how SQL Server points data in case of non-clustered indexes. So mostly when you have if interviewer asks that what is the difference between clustered and non-clustered indexes, we always say that in case of clustered indexes, the data will always be in the leaf level, but in case of non-clustered indexes, in the leaf level, we will have a clustered key, as well as we will have the pointer to the data. So here, these are the pointers, the row ID or maybe the index ID will be the pointer to the data. And in case of clustered index, we can only have one clustered index per table, but we can have multiple non-clustered index in any table. So this is about indexes. Now let's move to the interview questions. So first question is, what is the logical query processing order in SQL Server? For example, if we have many aggregate functions, we have where clause, order by clause, group by clause, having clause, and top, or maybe distinct. If we have everything in our query, how SQL Server processes that query logically? So for that, let me go to the SQL Server Management Studio. Here you can see we have two tables, department and employee. And we have 5 departments, and we have around 25 employees with the name, department ID, salary, and status. So some status are inactive as well, and most of them are active. And we have salary, department ID, and employee name, employee ID, and employee table. And we have department ID, and department name, and department table. So now what is our main focus here? If you see this query, so what this query is doing, it is trying to fetch the top 3 department names with the highest average salary among active employees. For example, if in the sales department we have 7 employees, then HR we have 8 employees, and IT we have 9 employees. So it is trying to so for example, in sales, it will check all the active employees because it is saying we need to check we need to check the department salary, average salary, where the active employees are 5. So for example, if sales have more than 5 and HR has more than 5, then out of those 5, for example, sales have 9. So those 9 employees' salary will be averaged, and we will have to get the average for all the departments where the employee count is more than 5. And whatever average salary will come, we need to order by the average salary, and we only need top 3 departments, right? So this is what the ask is, and if I will execute this query, then it will give us top 3 departments, and the average salary is shown descending as per the requirement, and the employee count is also mentioned here, right? So if we have employee count less than 5, those employees count will be not be mentioned, and we only have like top 3 departments. So let's see how the SQL Server actually execute this query. So first, SQL Server will go and check the tables. So here we are having the employee table. So this from clause will be executed first, and after that this join and the on clause will be executed. So because from there we are getting the data, right? After that it will go to the where clause, and it will check for all the employees who are active, and it will filter the data with this active employees. Now after that it will go and check for the group by. So it will group by all the employees who are active, and it will group by the department name. And after the department name, after the group by, the aggregate functions like count and average here in our example will be calculated and stored for the later part. So after this, where group by will be executed, once we will group by the department name, it will check whether the count of the employees are greater than 5. So it will again filter a second time, and it will remove all the departments where the employees are less than 5. And after this having, it will go to the select. In the select, we will have the top three department. We need to have like all these department name, employee ID, and salary. So those will be selected. And after the select, it will go and it will check the order by clause, and it will sort those average salary as per the order it is showing as description. Sorry, descending. So it will sort by the descending order, and at last this top will be executed. So this is the overall execution of or the logical sequence of execution of queries. So if you want to see the detailed video, I have already created this video, understand the SQL execution order of queries. You can go through it. I have shown everything in detail. So it will be good for understanding, because sometimes even if you are a DBA, people ask this question like what will be the execution order of the SQL queries, because it will help you if you understand this, it will help you to solve the slow queries or where the bottleneck is. Okay, so this is about execution of the queries. Next is the difference between truncate and delete. So there are multiple differences between truncate and delete. Let me explain. So consider that you have a diary where you are entering the name of every visitor in your hotel, and after some time, if you want to remove some names, so you just go and erase few of the names with eraser, and in separate diary you just keep the record like what records you have erased. So this is just our delete. So you can go and you can delete whatever row you want or whatever data you want. You can remove it by using the where clause, right? And the truncate means if you are simply tearing off that particular page of the diary and you are not even recording it, that is called the truncate. So other differences is you can say like SQL Server visits every row when you use the delete, and for each row it writes an entry in the transaction log that whatever we have deleted, and the space was so space will be the empty space will remains owned by the table itself, so it will not give away the space to the OS. So in case of truncate, it will minimally log the operation. It will not log like all the row by row, but minimal logging will be there. And in case of truncate, it does not fire the trigger, but in case of delete, it can fire after delete triggers. So these are the differences between truncate and the delete. Next question is, can having be used without a group by clause? So answer is yes, we can use the having without the group by clause. However, it will not be very efficient, or it is not being used due to inefficiency. Then we have in the context of durability, what happens if the database crashes after a commit is issued, but before the data is written to the MDF file. So in this case, what will happen? For example, it is saying that database is crashes after a commit is issued. So you know that when SQL Server issue a commit and after that database is crashed, so the data will not be written into the MDF file, but as we follow the write ahead logging, so whatever it is, whatever data you have committed, it will be written in the transaction log, and when the database will recover next time, it will be redoing all the transaction which are committed. So this is the answer of the question. Now we have a question like, if you see a lookup in an execution plan, what does that tell you about your non-clustered index? So it is very important. Let me go to the SSMS again and I will explain this in detail. But before that, let me read the question again. If you see a lookup in an execution plan, so when you see the execution plan and if you see the lookup, what does that tell you about your non-clustered index? Okay, so here here, just consider that we have created a non-clustered index on department ID column. So we have an employees table, and there we have employee ID, employee name, department ID, salary, everything we have. So we already have a clustered index in employee ID column, but after that we created a non-clustered index on department ID column. And in that case, when we create the non-clustered index in department ID column, so this will be the structure of the index. So in the index, it will have the clustered key, that is our index key in the department ID, and we will have the pointer to the exact data or the location. So the pointer will be the clustered key, right? So here, for example, in this table, if we have a department ID 5 and this department have 5 employees, so it will store the data like this. So it will have 5 times 5 because we have department ID at 5 times in the table. and it will have all the employee names who belongs to the, not employee name but employee ID who belongs to the department ID 5. So this is how the non-clustered index looks like. Now if we run the query, name, select name salary from employees where department ID equal to 5. So what SQL Server do, it will see that department ID has the, like the data is a non-clustered index and department ID, so it will come up here and it will see what is the pointer. So here we can see the pointers are the employee ID. So now for fetching all the records, it will move from here to the index key or to the table itself where your employee ID is there. So for example, if it matches 5 rows, then 5 times it need to switch from this non-clustered index to cluster index. And in the cluster index, it will find the name and salary, right? It will find the name and salary in the table itself. But in case there are millions of matches, for example, if the department ID 5 have around 1,000 or 10,000 of employees, so it will make 10,000 switch from this non-clustered index to the table. So the operation will be very costly. So whenever you see the lookup, it means it is not finding the whole data which is being requested in the query. Now after that, we have created a covering index. So covering index means including the column which is already like very frequently being asked in the query. So here we can see select name and salary in the query, and where we will have the department ID. So we already have our non-clustered index in department ID. So what we will do, we will include those two columns in the department ID or in the non-clustered index. So once we run this statement, then the non-clustered index will have now the name and salary as well. So this will be the structure of the non-clustered index after we include the name and salary column. So it will have a department ID, the basic one on which we have a non-clustered index. Then it will have the pointer, but it will also have these like these name and salary column as well. So what will happen next time when you run this query again, it will go to the department ID 5 and it will find the name and salary here itself. So it will not move to the table or it will not point to the clustered index. So this saves a lot of resources and a lot of cost as well. I hope it is clear to you. Now, next is why is it a bad idea to use a long varchar as a clustered index? So again, consider this example. If you are having like for example here 5 is the value of department ID. So instead of 5 will be the int, so int will take very less space. So instead of this, if we have for example name in this non-clustered index, or the name is a varchar and it's a long or maybe address may be the long one, and if you store this if you create a non-clustered index on that address column, it will be very long, it will be varchar, and it will take a lot of space because we have to store this non-clustered index separate from the table itself. So it takes a lot of space if you are creating it on the varchar column. So this is it for today. I hope you have got some new information in this video. If you really like this video, please share your thought in comments. I would be really happy to see your comments. And with this, I am ending this video. I'll see you in the next video. Till then, take care. Bye.